Hello fam, this is Zekaya from Entertainment, reminding you that enthusiasm implies excellence. We are extending our lessons on algebra, and today we are going to learn how to solve quadratic equations using a very special technique called completing the square. Before we even go further, let me emphasize that completing the square is actually not examinable in grade 12. However, we will include it as part of our lessons on algebra because it will be helpful to understand the upcoming lessons. So, without any waste of time, let me again define what a quadratic equation is. We define a quadratic equation as an equation of the form ax squared plus bx plus c equal to 0, where a, b, and c are all real numbers, and the requirement is that a must be different from 0 in order to make sure that we have a quadratic equation. Otherwise, we would have a linear equation if a is equal to 0. Now, let me plug you with a special routine on how to solve a quadratic equation using completing the square. Well, the first step there, when we are given an equation of the form ax squared plus bx plus c equal to 0, which is the standard form of a quadratic equation, the first step, you are required to make sure that the coefficient of x squared is 1. Make sure that the coefficient of x squared is 1. The second step, you are required to transpose the constant to the right-hand side. Transpose the constant to the right-hand side. Thirdly, take the coefficient of x, multiply it by 1 over 2, square the product and add it both sides of the equation. I repeat that one. You need to take the coefficient of x, whatever it is, multiply it by half or 1 over 2, square that product and add it on both sides of the equation. 4. Factorize the left-hand side. You must get the same factors. So now that's a clue that if you happen to get different factors, then you may have made a mistake when you were factorizing or anywhere above. Right. So whenever you factorize the left-hand side, you must get the same factors. Now, since the factors are the same, that leads you to your fifth step. That is, take one factor and square it. And then your sixth step is apply a square root on both sides of the equation. And then your seventh step, I just say solve for x, because whatever that you are going to come up with after applying a square root on both sides of the equation, which is step 6, that will be pretty simple. So that's why I say on step 7, solve for x. Things are now supposed to be simple from here. So let us apply this routine to a couple of examples here. We'll keep on referring to each step and we'll execute each step together in this example. The example says, solve for x by completing the square. That's what we are given, and we are required to solve for x by completing the square. By looking at that equation there, it looks like the equation is already in its standard form. It's in its standard form. And then the first step says, make sure that the coefficient of x squared is 1. And it looks like that coefficient is already 1. The coefficient of x squared is already 1. So we bypass the first step. The second one says, transpose the constant to the right-hand side. The constant there is -8. So we want to transpose -8 to the right-hand side. So we will have x squared plus 2x equal to +8, because when we transpose the constant to the right-hand side, it has to change the sign. So we have x squared plus 2x equal to positive 8. And now, take the coefficient of x. What is the coefficient of x? I'm going to write it on the side. The coefficient of x in this case is 2. Multiply it by 1 over 2. 2 times 1 over 2. Square that product. That's why I'm putting all squared. So what do I find there? 2 times 1 over 2, that is 1. And 1 all squared, that is 1. So the result there is 1. Take the coefficient of x, multiply it by 1 over 2, square the product, and add it on both sides of the equation. So now you see that the results that I come up with there, I came out with 1. So now I will come back to my equation and have x squared plus 2x plus 1 equal to 8 plus 1. And then the fourth step says, factorize the left-hand side, and you must get the same factors. So you see that the left-hand side, that's a trinomial. That's a trinomial expression. So by using your trial and error method there, you will see that the factors are x plus 1 and x plus 1. And indeed, they are the same. On the right-hand side, we have 8 plus 1, which is 9. So now, since the factors are the same on your left-hand side, that leads you to your fifth step, which is to take one factor and square it. So I will have x plus 1 all squared, because they are the same anyway, equal to 9. Now, I want to apply the square root on both sides of this equation. So I want to apply the square root on both sides. So if I put a square root there and a square root there, then I will have x plus 1 equal to plus or minus 3, because when we are applying a square root, we are getting a result there which is plus or minus 3. Now, from here, I just want to solve for x. From here, I just want to solve for x. So from here, I have x being equal to negative 1 plus or minus 3. So this means that x is equal to negative 1 minus 3, or x is equal to negative 1 plus 3. And therefore, x is equal to negative 4. This is one solution, or x is equal to positive 2. This is another solution. We all know how to confirm if our solutions are correct. Take these solutions and substitute them into the equation there, and you see if you get the sides that are balanced or the sides that are equal. Right, so that was one example. Now, for the second example, we are given an equation that we are supposed to solve by completing the square, and the equation is 5x squared minus 13x minus 6 equal to 0. The first step says, make sure that the coefficient of x squared is 1. Is that coefficient 1? No, it doesn't look like it's 1. So you want to divide everything by 5. On that equation, divide throughout by 5. There you go. And now we are going to have x squared with its coefficient being 1 minus 13 over 5 x minus 6 over 5 still equal to 0, because 0 over 5 is still 0. Now transpose the constant to the right hand side. That's the second step. X squared minus 13 over 5x equal to 6 over 5. And now the next step says, take the coefficient of x, multiply it by 1 over 2, square the product, and add it on both sides of the equation. So let's take the coefficient of x. It's 13 over 5. We want to multiply it by 1 over 2, and let us square the product. Well, to be on the safe side, let us use our famous calculator here. We are going to have 13 over 5 multiplied by 1 over 2 all squared, and then we are coming with 169 over 100. So that's what we are going to add on both sides of the equation. On both sides of the equation, we are going to add 169 over 100. So we will have x squared minus 13 over 5 x plus 169 over 100 equal to 6 over 5 plus 169 over 100. Okay, now I can erase that red part because I found what I'm supposed to add on both sides of the equation. So now, factorize the left-hand side and you must get the same factors. Well, there, by using your trial and error method, since that's your trinomial, you will see that your factors are, you have x going with 13 over 10. And another x is going with 13 over 10. And then the sign there, since it's positive, that sign, let me highlight it so that it will be clear. That gray sign there says the signs are the same. And now that you know that they are the same, that negative one says they are both negative. Hence, your factors are the same. On the right-hand side, we want to find that sum there. Let's quickly find that sum and see what we get. That sum is 6 over 5 plus 169 over 100. And we are getting 289 over 100. We are getting 289 over 100. We have 289 over 100. And now, what we have here, we can take one factor and square it since the factors are the same. X minus 13 over 10 squared equal to 289 over 100. And now we apply a square root on both sides of the equation. So what we get there, we are getting x minus 13 over 10 being equal to plus or minus. Let's see if we have a square root of 289 over 100. We want to find the square root of 289 over 100. Aha, we are finding 17 over 10. So the square root there is plus or minus 17 over 10. Well, this implies that our x there should be equal to 13 over 10 plus or minus 17 over 10. So from here, I will quickly write the answers. Now it's a matter of writing x equal to 13 over 10 plus 17 over 10, or x is equal to 13 over 10 minus 17 over 10. So in a different color, I'll use black. I will write x is equal to, and then I'll just punch these answers on the calculator just to save space. But one option here is that we have 13 over 10 minus 17 over 10. And for that, we are getting negative 2 over 5. So that's exactly what I'm going to write there. We have negative 2 over 5. That's one answer. Or another one is that we have 13 over 10 plus 17 over 10. 13 over 10 plus 17 over 10. And for that one, we are getting exactly 3. We are getting 3. Or x equal to 3. So these are your two solutions which we have found by using completing a square. We have found those solutions by using completing a square. Now, what if things get more general? Solve for x by completing a square, and what we are given there, we are given ax squared plus bx plus c equal to 0, where a, b, c are all real numbers and a is different from 0. Well, we are going to follow the steps again and see what we are going to come up with here. We will follow the steps precisely and see what we are going to come up with. Well, let's go. Following the steps, to make sure that the coefficient of x squared is 1, we want to divide throughout by a there. By doing that, this implies that I will have x squared plus b over ax plus c over a equal to 0. The second step, you want to transpose the constant to the right hand side. And that will imply that x squared plus b over ax is equal to negative c over a. Now, take the coefficient of x, and in this case, the coefficient of x is b over a. Multiply it by 1 over 2 and square the product. So what we are getting there, we are getting b squared over 4a squared. That's what we are getting. We are getting b squared over 4a squared. So that's what we are going to add on both sides of the equation. So here, this implies that we have x squared plus b over ax plus b squared over 4a squared equal to negative c over a plus b squared over 4a squared, because remember, you have to add this quantity on both sides of the equation. That's what the instruction says. Now, factorize the left-hand side, and you must get the same factors. By doing so, you will see that the factors are as follows. We have x plus b over 2a and x plus b over 2a. So these are the same factors. Then, on your right-hand side, you want to find your denominator line, and then we have 4a squared in your denominator line. A to 4a squared, it goes 4a times. And then 4a times negative c, that is negative 4ac. So there I have negative 4ac. 4a squared to 4a squared goes once, and 1 times b squared, that is plus b squared. That's what you have. And now, since the factors on the left-hand side are the same, you are allowed to take one factor and square it. That's your fifth step. Take one factor and square it. And now, on your right, you have 4a squared. Well, for simplicity, I'm going to start with the positive term on the numerator, which is b squared, and then I will have minus 4ac. I'm just doing this for simplicity. Now, I'm going to apply the square root on both sides. So if I apply the square root there and the other side, what I'm getting x plus b over 2a being equal to plus or minus. On my numerator, I don't really know what the square root of that quantity is. It just remains under the square root, which is b squared minus 4ac. All over, but on my denominator, I know what the square root of 4a squared is, and that is precisely 2a. So now, I have x being equal to negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. And now, I can write this as a collective. I can write x being equal to negative b plus or minus square root of b squared minus 4ac all over 2a by treating 2a as the lowest common denominator there. I can find the LCD to be 2a. Then when I'm adding the 2, I'm getting this equation here. This equation is famously known as the quadratic formula. This equation is famously known as the quadratic formula. So now it's very refreshing to see that the quadratic formula, which we normally use when we actually can't find proper factors using our normal trial and error method, now we see that this method is also a consequence of completing the square. So it means completing the square is actually the best in algebra. However, it's not examinable in grade 12. So now, this is just a message from us to you guys that if you can't find proper factors using your trial and error method and you are required to solve a quadratic equation, usually the question will be indicated there that you are allowed to round off your answers to a number of decimal places, then it should click on your mind that you are supposed to use a quadratic formula up front because you are unlikely to get your proper factors there. You are unlikely to get the proper factors. You don't have to prove it like this. You just have to use this formula, and it's usually given in the formula sheet. But it's so refreshing to see that it actually comes from completing the square. Well, this is how we end today's lesson on how to solve quadratic equations using completing the square. But I'm not leaving you guys alone. This is your problem to try. So this one is yours to try. You are required to solve for k here, not x. Let me edit that part. It's supposed to be k, not x. We are supposed to solve for k by completing the square, where k squared minus 6k minus 16 is equal to 0. So this is your problem. Please try it, confirm if you understood if you understood our lesson for today. Thank you. We are going to meet again on the next lesson, which will be on nature of fruits.